morning, and welcome to the American Public Works Association's Talking Top Tech webinar series. Today's panel discussion will be 1 hour in duration and is titled Talking Top Tech, 3D Technologies Edition. Due to the format of this program, it is not eligible for CEUs. My name is Rita Cassida, and I will be your facilitator today. I'm an education manager at APWA. I have a BS in Mechanical Engineering from Kansas State University and an MS in Engineering Management from the University of Kansas. I'm a licensed professional engineer in Kansas, and before joining APWA, I served as the Public Works Director for the City of Lewisburg, Kansas. A recording of today's program will be available in the APWA Members Library and on YouTube within a week. APWA members can log into the library to access the content free of charge. Not an APWA member? Take the members library for a test drive. Spend 2 weeks accessing all the materials in our members library for free. Look for the link to sign up in your email today after the program. Today's session is interactive, so if you have questions for our speakers, please type them into the chat pod. You can do this at any time throughout the program. When you're in full screen mode, you can access the chat pod by hovering the mouse at the top of the screen and clicking on the chat icon. Now it's time to introduce today's panelists. Dennis Randolph is the Public Works Director for the City of Grandview. James Michael is the Data Analytics Sales Engineer and Project Manager for Cyclomedia Technology, Inc. And Ben Linder is the Director of Operations for Linux. Our final panelist is Jonathan West, and he is the Senior 3D Design and Visualization Specialist for Kleinfelder. APWA is delighted to bring you such knowledge and experience. We are going to start the program with each of the panelists giving a brief overview on how they're involved with 3D technologies. Dennis, would you like to go first?
Sure thing. Thank you, Rita. Good morning, everybody. And the City of Grandview has been doing work in 3D printing now for about 5 years. And actually, the idea extends back a little further, closer to 10 years. We're a small city, 25,000 people, but you know, we have the standard complaints from folks about sewers and streets, and it's always an educational task. And what we have been doing for the past 5 years has been having various models made, and that's what 3D printing results in for us, a model, to show people how things work. We've done some display models for showing folks how a cross-section of a street looks with sewers. We have done mock-ups for bridges that we need to build when we're looking at alternatives. We're currently working on building mock-ups for proposed changes to City Hall. Our biggest task, though, and I think one that's been the most useful and that people have responded to the best, has been we've been developing a 3D printed topographic map of the city. And we've been using it for a variety of functions, and we'll hear about those, I think, as we go on. But we're always looking for ways. Again, it's a nice alternative, we find, or complementary to 3D graphics or our traditional printed plans. It just helps people to be able to feel the project much better.
Thank you, Dennis. That was helpful. James, would you like to go next?
Sure, thank you. So I work for Cyclomedia Technology, and the way we work in the 3D space is we have vehicle-based imagery and LiDAR sensors. We drive cities, and we produce imagery and LiDAR services that are web-based, software as a service. Users can view the imagery. It's extremely high resolution, a bit higher than Google's Street View, but you can also measure. So everything in the imagery and LiDAR is completely measurable by the user, heights, distance, length, anything you can think of. The other way we work with our 3D technology is we have our data analytics and feature extraction products, machine learning. So we can typically extract anything in a city, any objects, whether they're street signs, manhole covers, street lights. So city-wide scale, we go and we extract different features out of the 3D imagery and LiDAR so that different local governments and cities can have a robust asset collection, smart city initiatives, and everything is viewable by them so they can see real-time updates.
Thank you, James. Ben, would you like to go next?
Yes, thanks, Rita, and thanks to APWA for holding this forum. I think this is really exciting technology, and it's awesome to get to share our knowledge with this great panel with this group today. I'm the Director of Operations for Linux, as Rita said, and Linux is a new name you may not have heard. We're actually George Butler Associates, or GBA's newest subsidiary. GBA has a 50-year tradition of doing architecture and engineering projects in primarily the Midwest and some around the world. And they've got a really deep history with working with public works projects in particular. So as we've been developing technology to tackle transportation and water problems, we found the need to create a new company to actually help extend these technologies. And we do a variety of different modeling and different sorts of techniques to create products that really enable engineers to have better situational awareness around the projects that they're designing, and also to inform stakeholders in the community on how these projects will impact the surrounding areas. And we also actually build technology. We have our own in-house 3D printers, and we build a variety of devices. Some you might see behind me, different drones to capture different data sets that we need. We make drones that go underwater, in the sky, and on the ground. And we also use 3D printing technology to develop GPS correction systems so that when we get that data for the 3D deliverables, we can actually get it into the space that the engineers want to work in and provide the best accuracy possible. So do a little bit of modeling, a little bit of prototyping, and a little bit of manufacturing, and that's kind of our expertise over here at Linux. Thanks, Rita.
Thank you, Ben. And finally, Jonathan, would you like to give your overview?
Yes, absolutely. My name is Jonathan West. I've been at Kleinfelder for about 7 years and about 16 years in the industry. My main focuses in Kleinfelder are BIM management, 3D visualization, animations, virtual reality, GIS and GIS mapping, 3D printing, and all the connections between those things to help further design. A lot of what I'm focused on in the last year is building live or interactive 3D models for the purposes of education and understanding large-scale systems. Right now we're working with the Boston Water and Sewer Commission to build 3D models that are animated and linked into their GIS database so that individuals in their institution can open up models and check and see how it functions in different scenarios. So we provide scenarios showing animation of dry weather conditions, wet weather conditions, flooding conditions. This will allow them to predict ahead of time and to assess whether or not they need to upgrade infrastructure. We're also working with the City of Cambridge to do educational visualization on future infrastructure in relationship to climate change and future development. We use 3D printing, 3D scanning, and a myriad of online applications to show these things.
Thank you, Jonathan. Now it's time for our question and answer part of the program. So please put your questions in the chat pod, and we will answer those as they come in. The first question we have is actually for you, Jonathan. How would a team determine if it would be economical to explore a new technology or a new workflow?
That's a great question for most teams, and it really would vastly depend on the size of the team. Here at Kleinfelder, we have to ask ourselves several questions. And first, the question comes comes to light because a lot of technology is either cool or interesting or innovative or fun, but might not always be cost effective, or it may be at high risk to take on that technology. So we ask the question to begin with, and then we break it down into 3 areas. The first is, what are the benefits of the new technology? Is this something that the client wants? Is this something that's going to bring higher quality to the deliverable? Is this something that's going to bring a faster, more effective deliverable? Does it save money? A lot of the times, is this technology going to be costly up front and save money later, or is it going to save money up front and maybe cost more later? Or is this potentially just a good marketing tool? Sometimes we can integrate a technology into a project and it ends up being a wash in the project, but the technology itself is really good marketing for later on projects and a very good understanding of how we completed a project. With that value question in mind, we then ask, does this work with our design process? Is this something that we can integrate into our design process? Does it work with our current design tools? Or do we need to integrate other or new tools? And in that, do we need to train people to use this technology? Is this technology something that everybody in the company needs to learn, or do we just have to get a couple of specialists like myself up to speed with the technology? That can be a huge difference in cost effectiveness in using technology in the future. And last, we ask ourselves, how long will this technology last, and what's its robust nature in the industry? Is this something that's going to become an industry standard? Is this going to lead the industry into a new and better direction? Or is this something that will probably be superseded in the next 3 months, and maybe our investment will be lost?
Thank you, Jonathan. The next question is for Dennis, since you work at the City of Grandview. How do you convince the City Council, city administrators, that 3D printing is a worthwhile expense for your city?
Sure, and that's a good question, because it gets to how do they let me go on and do what I'm doing. I think I've always liked to start small, and for the work here in Grandview, that's exactly what we did. We had a problem in a neighborhood that involved backyard flooding. Okay, every city has that kind of problem. And to help explain that to the board, I made a traditional layers of cardboard topo graphic. Everybody does one of those in schools when you talk about maps, and it helped get the message to the board about how the lay of the land caused water to flow in certain directions. But what I also found is that it took me the better part of 2 weeks to make just a small little map. One's Christmas time, that was my vacation. And that wasn't really cost effective for me to do. The next time one of those items came up, I wanted to be prepared. And so we went into the idea we were going to do some maps of the city that the board could use, only do it a little quicker, maybe a little more accurately. We had a situation come up, actually flooding a couple of years ago, that the board certainly was interested in, needed to be able to understand and explain to folks. We rolled out a small section of the city, actually 4 tiles, that showed the flooded area, and it showed clearly in a way that the board could see that how the water flowed and what really happened. And I always tell people this to close the story. I brought the map into the board meeting, one work session. I had it covered up. I put it up on the table when it came my turn to talk, and I uncovered it. Immediately, all the board members got up and came around the table and started to touch the map. They could feel how the water went. And I think that just little demonstration of a real practical day-to-day problem they were having to explain to people convinced them that this was worthwhile, and I was able to go on from there. So you find something that is both educational but real practical. For us down in the trenches, we have to be able to put it to work. And like I said, it's this thing I've seen over and over with my topo map. People come up to it and they want to touch it and feel how the ground goes up and down, and they understand quickly what's happening around them. So that's my story of how we got going, and I think it's applicable to almost any place. Start small and go from there.
That's great advice. Start small and then just go from there. So I like that. The next question is for Ben. What new ways are being utilized to turn 2D data sets into 3D deliverables?
So I think the biggest technology breakthrough that probably happened in the last 10 years is there was a paper published that was called Structure Through Motion. And what Structure Through Motion enables is it enables a machine learning algorithm to go through a variety of different 2D data sets and to derive different information. I think the primary one that most people are using and most people might have experience with right now is to use it for photogrammatic techniques. Basically, we take a lot of images of the same object, and if you can identify different parts of that object in all those different images, you can use some basic trigonometry and you can create a 3D model from that. So that enables us to send drones into the sky and take hundreds or thousands of images of a site and create a topographic map or create a map of a building. You can also do this with video. So you can take a video camera and walk around your office, and you can put that video footage into one of these programs, and they can extract all the different still 2D information there and create 3D models out of that. Some of the more exciting technology that's maybe coming right now, some stuff that we're working on, is we can take these same principles and we can actually apply them to physics. So we're taking a variety of infrared photos right now of bridges throughout the course of a day, and by taking this concept of structure through motion and then adding some additional variables like the way that heat flows through concrete, we're actually able to detect things like bridge deck delamination below the surface, or delamination of concrete on dams, things of that nature. Also, some exciting things that we're looking at to do that with is possibly like finding plastic field mines in a field of grass. How do you tell the difference between a plastic mine and a rock on an infrared photo, right? And so these are some of the really neat, interesting things that are coming out of that. The other interesting piece, I think, is a lot of the traditional 3D deliverables that have been kind of marketed towards engineering professionals have been very minded towards people that really understand how to work with 3D data sets. And so some of the cool stuff that's out there right now, there's this, Leica has an inexpensive laser scanner, and what's really unique about that one to me is it takes these high resolution 360 images, which are just circular images, which are still 2D information, but it embeds the LiDAR information into that. And so that enables an engineer, rather than having to work with a complicated product like a triangle mesh or a point cloud, enables them just to look at a photograph that they can navigate and then measure all the different geometries behind it. So I think that's also really exciting. And then to kind of take more traditional 3D information, we've had a lot of success with taking geology information on like previous roadway projects, and now we can rasterize that information, or basically turn it into a bunch of little blocks, and we're able to display that information in things like GIS, MicroStation, AutoCAD. And so where at one point you just had some sections and kind of had to visualize in your mind how that looked in 3D, it's really easy to turn that into 3D products now with some of the tools that we have.
Thank you, Ben. The next question is for James. What are some of the features or objects that can be collected and extracted using imagery and LiDAR?
Thank you. So there's a long list of different objects and things that different cities extract. Local governments a lot of times are looking for signs, telephone poles, traffic information, traffic poles. We did a project with Washington, D.C. where we collected every street and parking sign in the city And since everything's collected in 3D, you get X, Y, and Z, so you even know the order of signs. So they found a lot of their signs were out of order from top to bottom, which someone like me that gets parking tickets from time to time can completely understand how important that is. One of our other big projects with local governments is ADA compliancy. A new realm that we've pushed into is using the really fine resolution LiDAR to measure ADA ramps. All corner ramps get 15 to 20 measurements made with the imagery and LiDAR to make sure that they're ADA compliant. We also do vegetation management for power lines. So you can, another new avenue using imagery and LiDAR in a 3D space is measuring how close vegetation gets to power lines. This is something really important in California right now, as we've had a lot of forest fires in the last year due to vegetation encroaching on lines and transformers. And then lastly, I think the other biggest projects we do are city pavement lines. All the different road markings, bus lanes, pedestrian lanes, the line condition, does it need to be repainted? So more and more cities are evolving into these smart cities, knowing what all their assets are, knowing what the condition is, knowing where things need to be. And as they start to get smarter, having very robust asset inventories is very appropriate. And not just that I have a light pole on this location, but that I have a light pole with an LED bulb that's metal, that's 40 feet high. When we capture and extract through imagery and LiDAR and machine learning, we don't just get that an object's there, we can get any number of attributes and qualities for that object.
Thank you, James. Let's see, the next question, I think Jonathan's going to start on the answer. What is the relationship between print versus digital and 3D printing versus virtual reality?
Yeah, there's a constant synchronistic relationship between those two sets of things, and we find that we're constantly potentially delivering both, or at least collecting information with the idea that we might do one or the other. For instance, for the city of Cambridge, we collected a whole lot of data on a very specific neighborhood that we were separating sewer and stormwater drainage. And as we collected that information, we found that our audience was a very diverse audience. And some of them were very tech savvy and some of them were not. And so to provide solutions for these educational materials or provide a better understanding of what we were doing on site, we found ourselves providing both a 3D print and a virtual reality situation. That way we could reach out to the right audience at the right time. And that tends to be our biggest question when it comes to deciding print or digital or deciding 3D printed or VR, is who our audience is. And we had to investigate that for the city of Boston, the city of Cambridge, the city of San Diego, and in Houston, where we wanted to provide the client with the right solutions, and we wanted to connect and show our design solutions thoroughly and with the best understanding. And so we needed to figure out who our audience was and which one of these technologies and deliverables would really speak most to the audience. Then we had to ask ourselves a little bit of the sustainability question. Is this a sustainable or an economic approach? For the city of Cambridge, with the diversity and the density of individuals, they wanted all of the above, all of the options. They wanted to see anything and everything. They wanted it digital so it would last, and they wanted it digital so that it wasn't just sustainable, but it was also something that was accessible. The accessibility nature of being able to see design solutions was also in conjunction with that. And I think that's true for print and digital, this nuance of which one is sustainable and which one is accessible. And the same thing with 3D printing versus VR, which one is sustainable and which one is accessible. And it seems to be a balance that we have to find for each situation, and tends to be something that is a fun and interesting challenge in the design process. Sometimes the solution is obvious, and sometimes it's not. I think we've seen in the past 20 years the wonderful segue between a lot of hard print material into mostly digital and digital deliverables. And I don't think we're going to get as an aggressive nature right now between the 3D printing and VR, but we are seeing a little bit of that duality and which one is preferred where. So it's a very interesting time to see that change and see where things are going to go in the future.
Thank you, Jonathan. So Dennis, you talked about like how you got started in the 3D printing, but what would you need to actually just start a project? How do you get one started?
Sure, that's a good question, because it really is easy. When we did our first project, we didn't have a printer. Actually, we still don't have a printer, although our city administrator has said you can buy a printer, which is, I think, a good positive indication that what we're doing is working. But we needed an idea. We needed to focus in on, and we needed to have some time so that we could time the rollout of the product. We didn't know how long it would take to make a topo map using a printer. And again, for local government agencies, timing often is you have to meet with a certain group of folks and you at a certain time, and you have to have your things together. So we use the services of a local consultant, and they simply acquired a 3D printer. They could do the manipulation of, in this case, digital terrain information that we used for our map, and developed the printer. But in the process of doing that, we learned a lot of things I think we can talk about later on about how to do things. But I think for us, we needed to have somebody that was tech savvy. Getting a 3D output can be difficult for people. You just can't go to the store and buy a 3D printer and plug it into your computer and it starts making things. It's not that easy, especially engineering grade work. So you need to have a good idea. You need to know what kind of time frame you have, and you have to have some tech savvy advice for that first project. But that's all you really need. After that, again, you start something small and you can continue on. We have continually developed, and as we've progressed over the last 5 years or so, we've built the components we need to our system, the different software that we needed to handle data. Like the Leica information, we rented equipment, which was really a neat way. We didn't have to invest in very expensive and delicate equipment. We were able to do things like that. So there are a lot of options right now. And the fact is that as time's going on, it is getting easier because there are a lot of folks who are learning how to do these things. But again, there's always a jump between making cartoon pieces and making engineering pieces that can stand up to the rigor of what engineers need to, even in a presentation, to show folks. So again, you don't need a lot. We didn't have anything, just an idea, but you do need to understand that it takes time to do these things, and that's probably the biggest thing I tell everybody in this. If you've got an idea, make sure you don't need to print out tomorrow, because it'll probably be a little tough for you to get. Although I'm sure some of the folks here speaking today could get you some good stuff out really quick.
Thank you, Dennis. Always timing is the key. So, yeah. Ben also wanted to add to that answer.
I did. I think Dennis made a really good point, and that is this stuff takes a village, and it's really important to find the appropriate domain expert so that you don't spin your wheels and waste a lot of time trying to figure out stuff that other folks have. So it's a really good idea to find either a firm or an individual that can understand how to work with the different 3D technologies. So for instance, on our team, like we have commercial pilots that know how to operate the drones, and then we have specialists that know how to operate the printers and keep the printers maintained and doing those sorts of things, and really combining those two. And then it's also really important to have champions. When we have a champion on a project that's willing to learn a little bit of what we know, that really helps move it forward. And, you know, that person not just trying to do it all themselves, but really bring in the right experts, but be that driving force. Because all this technology can be a little uncomfortable at first when it starts to enter into our workflows. And I think a good way to get past those barriers is to make sure you pair the right technology experts with the right domain experts. I don't know anything about bridges, but I know a little bit on how to model infrared imagery, right? And when we put our forces together, we can come up with some really unique situations, you know, really unique deliverables.
Thanks, Ben. And as far as, you know, joining your forces together, if people don't do that, they're missing that in setting other projects. But is there other things that projects might miss when they're looking at 3D modeling and setting them up? Is there some common things that people leave out when doing their projects?
I think the main thing that people miss is, what are we really trying to get out of the model? So, for instance, we've worked with some wastewater facilities, and they say, can you model our facility? And that's kind of a scaled question, because, yeah, we can model down to every screw in every piece of machinery that you have, but that's probably not cost-effective or time-effective for what you really need. So really understanding what you're trying to derive from the model, what having modeled is going to help you in a situation later, or help you in a design project, or help you in a maintenance scenario is a big deal. Understanding the accuracy of the type of product that you're trying to use. There's several $100,000 LiDARs that we can fly on a drone that will give you extreme accuracy, but it's very expensive to get the type of equipment you need to operate that. So maybe you don't need that, and maybe a $1,500 piece of equipment with a really good photographic camera is good enough. And so really finding the experts that understand where those different accuracies lie, and then pairing that to the project. And the other big thing is datum corrections. So I've got some really awesome programmers and GIS specialists on my team, and it drives them nuts sometimes when they work with the civil engineers and the surveyors, because civil engineers and surveyors are trying to design things to the real world, and they're using all these localized transformations of the data. And the computer scientists and the GIS folks, they say, well, this is all just being represented in 2D space. Why are these things matter? And they are very important. So gaining some cross-industry, I guess, expertise in that area can really help a project either be successful or be a failure when it comes time to actually get what you were trying to get out of that. And also understanding the effects of, again, that accuracy question when you are doing those transformations between different datums. I think that is something that we've found to be a big thing. And the other thing is, don't strive for the perfect model of the perfect world. I don't think it exists. Really understand what is good enough, what is going to give us the information that we need to tackle the problem we're trying to solve. Thanks, Rita.
Thank you, Ben. Dennis, did you want to add to that answer as well? Or Jonathan, did you want to add to that answer?
Yeah, I just wanted to confirm, and I guess piggyback off of what Ben was saying, which is extremely valid in a lot of these situations. Understanding what is the intent of the model is extremely valuable up front. Asking the question, as soon as somebody asks for a model, it's like, what are our goals? And even potentially looking at, what the model's future goals might be, to make sure that as it's approached, that the potential options are fulfilled without going in more than what you need to go in more on. We can model things forever. I could spend a year on a single room just adding details for no benefit. But asking that question, what are we trying to get? What's our goal? And to his point as well, in regards to datum's real world analysis, GIS, and making sure that the model's fulfilling its goals, asking who's going to use it along with the goals. After determining what it's going to be used for, who are the people that are going to use it? Are we handing this over to a civil engineering team? Are we handing this over to an architectural BIM team? And how do we make sure that that translation works and that they get what they need to get without having to start over again? I've seen a couple of projects come, onto my plate where it was just started the wrong way, with good intentions, but it ended up being a situation where it cost more money to fix the problem than they had already spent on creating the model, just because it wasn't working with the designers that needed it. So I would definitely boost the question of getting datums, coordinate systems, figuring out who this is working for, and building to what your needs are and not more.
Yep. Yeah, Rita, I might add that we're doing a current project right now, a BIM project, modeling City Hall for some future changes, and it goes to a couple of comments that have been made so far. We're using several different systems in the project. We've done simulations of queue lengths and people moving on 3D programs to calculate things like how many stations you need for service and where people should be walking. And then we're transferring now to using our 3D modeling to actually show how walls and building components can be moved around. And in this case, a model helps people feel those walls and things a lot better than the 3D fly-through, which are quite nice, but it's picking the right process to show what's going on and to get the right message out there. I think that's probably one of the most important things to say, because there are a lot of different things that we can do. As we started that project, the building project, we realized that we had to spend more time using BIM programs. We use Rivet, but it wasn't something that we always had done anything with in the past. So it was a matter of gearing up for that and gearing up on how do you move files from one system to another. Our next step when we have our model done will be to provide it to an architect so that they can do their architectural drawings to help us get a project out to bid. And again, we're going to have to see and make sure our files are compatible and can be moved, and that everybody can talk across all the different pieces of software and the different technologies that we're going to have involved in this program. So it isn't, as you go through one of these projects, you'll find that pieces and new pieces always keep entering the picture. And what you have to realize is that doesn't mean you've been doing anything wrong. It's just that you're applying technology in different ways, and you're using a bunch of different types of technology to solve a particular problem, which is there isn't one big black box that you can put something in the front and get all the answers out the back end. That's always been kind of our quest in engineering, but it's not something that has ever gotten there. And I think this is a particularly good example when we're doing 3D modeling, because you can use all different types of models. Again, you have to pick the audience, you have to know what they need, what particular audiences need, and you have to know what you're trying to tell folks. and just keep adding the pieces as you go along and not be discouraged by what might seem to be a lot of side roads.
Thank you, Dennis. Mike had a question. Do any of the panelists have examples of their 3D prints to show either on camera or on a website? As far as a website, we're going to send it after program email probably in the next week or so. So we'll collect some links that we can share with you so you can look at those, with look for that email that'll come out. But Ben actually has some things behind him. Ben, do you kind of want to point out what things are 3D printed behind you?
Yeah, so we'll start with this. I don't know if anybody's ever seen one of these. This is one of the more popular drones out there. It's called a Phantom 4. And this drone has a really good camera on it, and it's really good at taking pictures and video. What it's really bad at is knowing where it's at in space. And so what we've done to this one is you see this little antenna mount. So that's a 3D printed piece that we make in the office. It's about 10 cents worth of plastic done on a $600 printer. And it allows us to put a high accuracy GPS antenna on it. And then on the back, what we've done is these are 3D printed legs and a standoff. And this whole case, if I can get this to come out on camera, this is dangerous. So this whole case right here actually contains the electronics for doing the GPS correction. And so what this allows us to do is this drone normally knows where it's at within about 10 meters of space, so, you know, like a city bus. And by putting these 3D printed parts on here with the electronics inside of it, we're able to correct the photographs down to about a golf ball of space, or about 3 centimeters. So that's really cool. And then also, we need a correction device. We need a localized file. So this is a prototype right now. It's kind of rough. I don't know how well this is going to show up on camera. But we're actually creating our own localized correction, and this is a prototype that my team's working on right now. And we can print one of these in a day, go out in the field, give it a good try, and see how that works. And again, it allows us to get into technology for thousands of dollars, not tens or thousands, or hundreds of thousands of dollars, and see if we can apply it directly to projects. And then one of our other big successes last year, we had a lot of flooding in this part of the world. And so we were able to use 3D printing to take some inexpensive sonar and GPS equipment and put it on boats, and we were able to go check scour holes that were affecting bridges that they were trying to get back open to get community safe. So that's just some of the examples of what we do. There's a million other ways that you can use 3D printing, but these are some of the actual products that we create in the office every day.
Yep.
Thank you, Ben. I really like that. I think Dennis, you had some things you wanted to share.
Yeah, I've got again. This is the current project we're working on the City Hall model, and this is actually I'm sitting right here in this model, right at this point. But this again shows the data that we again use rented equipment to do the LiDAR work, and then move that over to our consultant who plotted this out for us. This is the piece that convinced the city administrator to let me buy a printer. So it worked well. One thing I might mention, and I think it was mentioned earlier, yeah, we can get all kinds of detail, but on this you see just the walls. Because the fact is, and we did print some furniture out, it gets every piece of furniture or pencils on your desk, but that's extra cost, extra time, extra money. And if I want furniture, there are a lot of catalog pieces that are out there that have already been prepared that you can use that can be printed out quickly and easily. And there was no reason to spend our processing time for the outline, because that's what's important to us, showing the outline of where we might want to move walls and the flow of people. And we could have the furniture done through other methods on other machines. Again, processing is important. You need big, powerful machines to process these files. They're big files, and anything you can do to keep processing time down is helpful for you, both in cost and in getting a product that someone can see. I also had, this is a bridge that we're working on. Actually, I'm hoping to get money for it. And this is the model that we had when our folks who wanted to design the bridge came up with these, and we had these when they did their proposals so that we could show the Board of Aldermen what we had in mind in terms of a brand new bridge for the city. And again, it worked well. I think people see it and they say, okay, I understand what you're saying really easily. And this is almost kind of one of those standard things. If I want people to work on a bridge for me, I'm almost going to expect that you come in as an owner and you be able to show me these types of things so that I can look. This is conceptually for me, for a board, for a city administrator, this is a lot easier to understand than handing them a roll of drawings and saying, this is what we're going to do, because that just doesn't work. And just one last one I had, we did a model to show people how a road and the sewers and all the underground facilities worked out. And the first thing we turned out were manholes for our model. And even the model is nice. It's up at the front on our front desk so people can see it when they come into City Hall. But I think just having something like this, people, when they come and have a concern about sewers, they don't know what things like this are. They don't know what that manhole in front of in the street is. This helps me to show them what's there, and they often feel a lot better. It's the big question we're going through right now with COVID. How do you explain science and engineering to people who don't really need to know all the details, but still what the details are impact them? And this is a really nice way to do it.
Thanks, Dennis. I enjoyed looking at all those models, so hopefully someday I'll get to see them in person. Jonathan, would you like to add to the conversation?
Yeah, so kicking off of the subsurface of the sewer, we were exploring different ways of helping the Boston Water and Sewer Commission connect 3D models with their GIS database. And in doing so, we were reviewing as-built plans and building 3D models from them, doing some test sprints to see where we wanted to go. And we actually ended up exploring a little bit of custom hardware while creating custom hardware to explore some of these sewer systems. We sent drones into sewer systems to collect visual data and compare it to existing condition plans that we'd received. With Boston, the existing condition plans were sometimes 100 years old, or sometimes there were 10 variations of a plan and we didn't know what was actually there. And in doing so, we actually started experimenting with 360-degree photographs inside of the sewer system and inside of the manholes. Anytime we can enter a cavity. To get the 360-degree photographs, we were 3D printing custom camera mounts that were little teeny mounts to make sure that the camera was stabilized and hung on a single cord. And as we started exploring these little camera mounts, we also started exploring adding lights. Because we're sending a camera down into a dark hole, there's not an even or keeled lighting system. So we actually explored lighting the line with fiber optics that was holding the camera, get an even glow going down into the sewer system. So we ended up using 3D technologies in various different methods, both for creating hardware that was useful to collect the data so we can make the 3D models that were digital.
Thanks, Jonathan. Dennis, you talked about the time is required for 3D printing. Are there any downsides that people should consider with 3D printing projects besides it'll take some time?
Well, I think moving data back and forth, as I just finished mentioning, has been a trouble since the day I started programming back in the late 60s, getting different programs to talk, even when they're set up to do that, different versions of software don't always do things the same way. I'd say the old how do you move data between platforms is probably the thing I'd caution folks on first. I think the other thing is that in learning how to deal with 3D printers, and you know they keep getting better and better, but dealing with temperatures and where you put a printer, and you have to watch over it, and we had to go through a significant learning curve, a steep learning curve on just how do you get the print to come out. And materials change. We've had problem getting certain types of materials since the beginning of the year between trade restrictions and things like that with China and general COVID lack. We've had trouble getting materials. We've had trouble, again, as we upgraded machines over and over again, the problems go away, but that's a concern. That's why I mentioned you might be able to print some of the cartoon level things out quickly, but if you want to have something that looks like a piece of engineering work, printers are really key. So be prepared to go through a printer learning curve.
Thank you, Dennis. The next question is for James. What is the resolution, point density, and GIS accuracies for your imagery and LiDAR?
Yes, thank you. So Cyclomedia produces imagery and LiDAR. The imagery is a 1/4 of an inch resolution, typically. So again, very fine to the point that we can read anything off of signs and things on buildings, even at 10 and 20 yards away from the vehicle. Our LiDAR point density, that again, the LiDAR is what builds all the 3D models that go in behind the imagery and that get used for measurement. The LiDAR point density is 2,500 points per square meter. So again, very, very dense LiDAR, so we're picking up very tiny things, and that's how we can measure subtle slopes of curb ramps and, you know, power lines. The accuracy built into our GIS system these models get built on, typically for absolute positional accuracy on Earth, we're within 4 inches. So if we create a model of a telephone pole, you can pretty well reassure that that telephone pole is within 4 inches of where it is on Earth. And if we do any relative measurements, like the height of that pole or diameter of that pole, those are typically within 2 inches of accuracy. So all of the imagery modeling we're doing with the LiDAR, all the feature extraction, again, very high resolution for visualization, very accurate to have updated, you know, GIS assets. That's a big problem in the community with a lot of handheld devices. Even when I go running, my phone constantly thinks I'm in the road, even though I'm on the sidewalk next to the road. A lot of handheld devices and aerial can be off, you know, by 3 to 6 feet. So we're really helping Public Works know that their assets are there, you know, within 4 inches.
All right, thank you, James. I wanted to mention, I'll put it in the follow-up email, but the Engineering and Technology Committee just created a LiDAR toolbox. If you don't know anything about LiDAR and want to learn a little bit more about it, we'll send that out for you. So that's a nice tool they've developed recently. The next question is for Ben. How can 3D better inform 2D design?
So I think the big takeaway there is just the fineness of how we can get products now. So I think a lot of people have worked with Google Earth for a long time, or you may have a county or a state mapping program, and you've worked with what's called orthorectified imagery. And really what that is that's just a fancy word for how do we get rid of the perspective distortions in an image. So if something's further away from you or closer to you, it's going to have a different scale on an image, right? And so if I want to measure a roof versus measuring the street, I want to make sure that those those measurements in a 2D environment are correct. And so we use orthorectification to do that. And we've been doing that for a long time in mapping, but now being able to do it at finer resolutions like sub-quarter-inch imagery, like Jim was talking about, we're able to create these really high-resolution data sets that you can lay straight into CAD, and it's going to, first of all, align with the datum that you're designing the project with, and you're going to be able to get those really good 2D measurements out of that. Other thing is just situational awareness in general with those products. If you look at your standard mapping products that aren't using these high-resolution 3D data sets behind them, you know, you're not really able to determine what type of manhole you're looking at or things like that. And with these new data sets, we can read the manholes. You can actually see how many bolts are in the manholes, all sorts of information that you never had before. One of the ways that we've used these high-resolution 2D images that are created from our 3D is we did a large sewer project for the city of Peculiar. And in that project, we were actually able to look when we were trying to determine where construction easements would go and see, you know, who has the really expensive landscaping in their backyard, where are the retaining walls at, who's got tons and tons of rose bushes. So when we're making those cost determinations about how to put those easements to design this project, the engineers get that situational awareness. And then also class detection, working more on the building side, on the interior environment, being able to actually 3D model out these different systems and make sure that they're not going to clash with the existing systems or anything like that, to then put them back into 2D, I think is a really big benefit. Thanks, Rita.
Thank you, Ben. Well, I think that's all the time we have for today. I want to thank Dennis and James and Ben and Jonathan for sharing their knowledge and experience with us today. I've learned a lot, actually, so I think this is a very exciting program to watch. So this is Rita Cassida, and it's been a pleasure moderating this program for you today. Please remember that there's a new program in September called Talking Top Tech, Technology for Field Crews Edition. So go ahead and register for that. It's Thursday, September 24th, and it's at 10 o'clock Central. Don't forget to fill out the evaluation form. The link to the survey will be emailed after the program today. And due to the free format of this program, it is not eligible for CEUs. A recording of today's program will be available in the APWA Members Library and on YouTube later this month. And APWA members can log into that library to access past Click, Listen, and Learn, Talking Top Tech, and conference content free of charge. If you're not an APWA member, remember to take the Members Library for a test drive. Spend 2 weeks accessing all the materials in the Members Library for free. So you can look for that link at the email after today's program if you're interested in that. And I just want to thank you for your attendance and participation during this program today, and have a great day.